Hey class, let's learn how to name alkenes, alkynes, and benzene derivatives for nomenclature chapter 2. Okay, so I would say if you understood everything from chapter 1, this chapter is going to be a lot easier for you. It's basically built on top of that. So we're going to look at the naming for alkenes and alkynes first. I would say these two are pretty similar. If you understood one, you will be able to name the other one. The only difference is the suffix. Okay, for alkenes, if we look at these two structures, how should we name the one on the left? From chapter 1, we know that this should be pentane. So for alkanes, we have the suffix ane. All right, what if we have a double bond in there? How do we name it now? So we'll change the suffix from ane to ene. So in is the suffix for alkenes. You change one letter from A to E. So this one would be pentene. Okay, the next thing is to pick out the parent chain. So for alkanes, the rule was to identify the longest chain. So for the structures on the left, which is the backbone, we'll just look for the longest continuous chain, right? So it's going to be how many carbons? 8 carbons. It's going to be an octane. What about for alkenes? For alkenes, the rule is to include the double bond. So your parent has to include this double bond. Even though the horizontal chain is going to be longer, but we have to include the double bond. So the parent is actually a heptane. So we'll say include the double bond. Okay, then we'll have to number the parent chain. Which direction should we go? Like for this molecule shown here, which direction should I go? I can identify the parent chain first, which is the horizontal one. If we think from the rules of the previous chapter, we may want to number it from the right side to the left side because that will give the alkyl groups the smallest number. However, for naming alkenes, we have a rule overrides that. We want the multiple bond or pi bond here to receive the lowest number possible, despite the presence of alkyl substituents. So in this case, we will number it from the left side. Okay, because you can put this double bond anywhere on this chain, so in order to accurately reflect the structure, we want to use a locant to indicate the location of the double bond as well. Because double bond actually occupies 2 different carbons. Here it's carbon 2 and 3. So when we indicate double bond, we actually want to use the smaller number. So the smaller of the 2 numbers designating a multiple bond. So we want to use a single locant. Okay, now can we try to put the names together for this structure? So the same rules for naming substituents applies. I would put substituents first, which in this case it's going to be 5,5,6 trimethyl, and I want to put indicate the double bond location with 2-heptane. So we can name it this way, following the rule by IUPAC around 1978. However, in a later on recommendation released from IUPAC, it's actually recommended to put this location number 2 for multiple bond right in front of the suffix. So we're going to insert it here. So for the same structure, we could also write as 5,5,6 trimethyl hepta-2-ene. Okay, so this is more commonly used, even though both are considered correct. So we're gonna following this more recent rule from now on. Okay, if you want to pause the video and practice naming this structure. Okay, let's take a look. First, identifying the longest parent. No, actually, the parent that include the multiple bond. The longest chain include the multiple bond, which is going to be, and then identify substituent. Number, from which direction? Up, so that you can give the multiple bond the smallest locator. Now, rank the substituent alphabetically: methyl, isopropyl, ethyl. So I should start name from 4 ethyl, 3 isopropyl, 2 5-dimethyl hepta-2-ene. Is that clear? Okay, so the next one is naming alkynes. As I mentioned earlier, the only difference is the suffix. So going from ene to yne, alkene to alkyne. So pentane, pentene, and this one would be pentyne. Okay, be careful when you draw out alkynes. When you draw out alkyne, we want to draw the bond linear for the triple bonded carbons. Like in this case, for double bond, we can draw an angle of 120 degrees. For triple bonded carbons, we always want to have a bond angle of 180 degrees. So why is that? If you look at the hybridization for this double bonded carbon, it's going to be sp2. So the geometry of sp2 carbon should be trigonoplanar, and for this carbon it's going to be sp, the geometry is linear, right? So for triple bonded carbon, always linear, let's say. And when the triple bond is in the end of the molecule like this one, we actually call it a terminal alkyne. Sometimes this triple bond will be in the middle of a molecule. Like in this case, you have 2 more carbons on both sides. We actually call it internal alkyne. These 2 types of alkyne will have different reactivities. Okay, now if you follow all the other rules from alkene, how should we name this molecule? If you want to pause the video and give it a try. So it's going to be very similar. You have to number from the side that gives the smallest number for the multiple bond, and just identify the substituent. It's going to be the same 5,5,6 trimethyl hepta-2-yne. Is that clear? Okay, so everything is the same with alkenes except for the suffix. All right, now we're gonna look at both alkene and alkynes together. So for cycloalkenes and alkynes, how should we name them? We want to assign numbers to the carbons that bears the multiple bond 1 and 2. So it's always multiple bond gets 1 and 2, 1 and 2. So for this ring on the left, it's called pentene. Sorry, cyclopentene. So that we don't have to indicate the location in the name if it's only one multiple bond. Like for the structure on the right, it's going to be cycloheptene, because it's understood that the triple bond get carbon 1, 2. We don't have to indicate hepta 1 ine or cyclopent 1 ene, right? So to fill this blank here, number in the carbons of the ring so that carbon 1 and 2 are both part of the multiple bond. Okay. Okay, now what if the locator number for the multiple bond is not affected by which direction you number the chain? Which direction should I go from? Like in this case, on the left side, either direction of the backbone will give the triple bond a locator of 3. So intuition from last chapter will tell you should number from the right side. 1, 2, 3, 4, 5, 6, so that your substituent will receive the lowest number. Your substituent should have the lowest possible set of numbers. Okay, so if you want to see the structure on the right, which direction should I go from? I know that this double bond will get 1 and 2, but should I go clockwise or counterclockwise? 1 and 2, or should I go like 1 and 2? Which one will give methoxy group a smaller number? It's going to be this way, right? So that methoxy gets 4. If you go clockwise, methoxy would get 1, 2, 3, 4, 5. So we want a methoxy to have a smaller number. So if I were to name this molecule, it's going to be 4-methoxy cyclohexa 1 ene. You could always omit this 1 because by default, the multiple bond get 1, 1, 2. Now, if you want to pause the video and try problem number 2.4. Okay, let's look at it together. So for A, which direction should I name it from? Of course, going from left. 1, 2, 3, 4, 5, 6. So your multiple bond get a smaller number. So how should we name this one? Hexa 2 ine, right? Okay, for B, number the parent first. 1, 2, 3, 4, 5. So whenever you have an alkoxy, it's always a substituent. So this is going to be ethoxy, this is going to be methyl. When we name it, we should go from the direction of 4-ethoxy, 4-methyl, and pentene. For linear alkenes, we should indicate the location for the multiple bond. 1 ene. Is that clear? Okay, and the last one, numbering from the right direction, and we're gonna have 4-dichloro pent-2-ing. Is that right? Okay, now let's take a look at problem 2.5 if you want to pause the video. For rings, we know we always want to give the multiple bond 1 and 2. So it's a matter of which direction you number. In this case, we want the methyl to have smaller number, so we should number it from clockwise 1 to 3. So for this one, we should name it as 3-methyl cyclohexane. You can always omit this one, cyclohexane. Alright, for B, should we number it clockwise or counterclockwise? In order for chlorine to receive a smaller number, we should do it clockwise, right? The name for B would be 3-chloro-cyclobutadiene. Alright, the last one, clockwise or counterclockwise? Probably this direction would give bromine a smaller number, so I will number it clockwise. Clockwise, yes. No, actually counterclockwise. So bromine would be on carbon 4. It's going to be 4-dibromo cyclopentene or cyclopent-1-ing. Is that clear? Okay, we'll stop it here for part 1.